Okay, let's go ahead and start. This is on chapter 1. We got our first section, linear equations. So let's take a look at that. The solving linear equations. Our first step is to get rid of parentheses. And we do this via the distributive property. Our second step is to get rid of fractions. And we multiply by the LCM of all the denominators. Step 3, get all the terms, and I'm going to put this in terms of x, but you can have any variable. Get all the terms with x in them on one side, numbers are constant terms on the other side. Step 4, divide both sides by the number in front of the x. Okay. Let's take a look at a problem here. And I'll look at number 17. We've got 4 equals 7 minus 3 times 4t plus 1. Different variable, but then same idea. Now our first step was to get rid of parentheses. And we do this via the distributive property. So we're going to take this negative 3, multiply times the 4t, and multiply times the 1. So I got 4 is equal to 7. Negative 3 times 4t is negative 12t. Negative 3 times 1 is negative 3. Now, no matter where you are in math, if you can combine together like terms, you can combine together numbers, you should. Here we have 7 minus 3, which gives us 4. And step 2, get rid of fractions. Don't have any. Step 3, get everything with t on one side, numbers on the other side. So all my variable terms on one side, my constant terms on the other side. So I'll take this 4 and move it to the left side. So we've got 4 minus 4 is equal to negative 12t. 4 minus 4 is 0. You always combine together numbers, combine together like terms. And then step 4, divide both sides by the number in front of your t, the coefficient. So divide both sides by negative 12. And 0 divided by anything is 0. So that would be our answer. Now let's look at another one. I want to look at a fraction. Number 29. It looks like an interesting one. We've got 1/2 w minus 3/4 equals 2/3 w plus 2. Okay. Step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. Multiply everything by the LCM of all your denominators. We got 2, 4, and 3. Our LCM would be 12. So I'm going to take 12 times 1/2 w minus 12 times 3/4 equals 12 times 2/3 w plus 12 times 2. When I say multiply by everything, I'm talking about what's separated by pluses, minuses, and equals. That's why I multiply by this first fraction. Here's a minus. That's why I multiply by this fraction. Here's an equals. That's why I multiply by this fraction. Here's a plus. That's why I multiply by the 2. Now 2 and 12 are both divisible by 2. 2 divided by 2 is 1. 12 divided by 2 is 6. 4 and 12 are both divisible by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. 3 and 12 both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. You notice that all of our denominators have disappeared at this point. If you multiply it by the correct LCM, that'll occur. Now 6 times 1 gives us 6W minus 3 times 3 is 9 equals 4 times 2 is 8W plus 12 times 2 is 24. Step 3. Get everything with a W on one side, numbers on the other side. So I'll take this 8W, move it to the left side, take this negative 9, and move it to the right side. You move anything across for equals, your sign changes. So the 8W becomes a negative 8W. The negative 9 becomes a positive 9. 6W minus 8W is negative 2W. 24 plus 9 is 33. Then last step, step 4. Divide both sides by a number in front of your W. There's a negative 2 there, so we'll divide both sides by negative 2. Then we get W is equal to negative 33 over 2. Let me just double check that real quick. 6W minus 9 equals 8W plus 24. Okay, took that over there. There's negative 2W. Took that over there, 33. Yeah, sure enough. That's solving linear equations. Now the next topic is identifying conditional equations, identities, and contradictions. So I'm working a problem down, solving it just like normal. And I end up with answer, x equals 2. We have conditional equations, identities, and contradictions. If you come up with an answer, that's a conditional equation. So this would be a conditional equation. It means that x equals 2 is, or the equation is conditionally true when x is equal to 2. Working a problem down, and all of a sudden my x disappears, and I end up with something like 3 is equal to 3. Well, we ask ourselves, when is 3 equal to 3? Well, 3 is always equal to 3. Now you might get 1 equals 1, 0 is equal to 0, but your variable is going to disappear, and you'll have something that's always true. The identity. Identity is what this means. Means that no matter what value of x I put into the original equation, it'll be true. If I plug in x equals 3, x equals 7, x equals 1, x equals 1 million, no matter what I plug in, the equation will be true if I go through and check it. Working a problem down, and all of a sudden my x disappears again. And I get something that looks like this. And we ask ourselves, when is 2 equal to 4? And it's never equal to 4. Now this is a no solution. That's how I like to refer to it. But the book here refers to this as a contradiction. So that would be a contradiction. So that's how you identify the different types. You solve them like normal, and you see what happens. Now, next topic is rational equations. So let's take a look at those. Now, a rational equation is an equation with a variable in the denominator. So keep that in mind. To solve a rational equation, our first step is to get rid of parentheses, although very rarely do they ever have parentheses in them. We still do that via the distributive property. I won't write that down again. Our second step is to get rid of fractions. And when you're talking about the harder problems, your first item you have to do to get rid of the fractions is usually factor all the denominators. Second item you have to do is figure out the LCM of all the denominators. Then the third sub-step under step 2 is to multiply everything by the LCM. Then step 3 is solve for x. That's kind of vague. At this point, it'll be a linear equation, and if it is, use the 4-step method from above. Or it'll be a quadratic equation. Quadratic means you got an x squared. Linear means you just got x to the first power. And here we'll use the zero factor property. And we're going to talk more about solving quadratic equations later on. Okay, so those are going to be our steps. Actually, I was going to put this as a note, but let me put it as a step. Then semi-check your answer. We'll talk more about what that means. We don't have to fully check it. Okay, so let me clear off the tablet here. And let's take a look at a problem out of the book. And down to some a little bit harder ones. Let's take a look at number 63. We got 5 over x squared minus x minus 2 minus 2 over x squared minus 4 equals 4 over x squared plus 3x plus 2. These steps are best shown with a problem a little bit harder. Now, first step is get rid of parentheses. Don't have any. Second step is to get rid of fractions. And the first sub-step within that is to factor all the denominators. This first one is the PSD method. Because we got x squared x, no x, there's no number in front of our x squared. The second one is dots, because we got two terms minusing it. And this last one is PSD, because we got x squared x, no number in front of our x squared. So this becomes 5 over x minus 2 times x plus 1 minus 2 over x plus 2, x minus 2 equals 4 over x plus 1 times x plus 2. Now, B and C kind of go together. So first look at 2B. Figure out the LCM of all the denominators. So I start with my first factor. I start with the x minus 2. And I'm looking for the greatest number of x minus 2's in a single denominator. There's one here, none here. So the greatest number of x minus 2's in a single denominator is 1. Then I go to my next factor, the x plus 1. And I'm looking for the greatest number of x plus 1's in a single denominator. There's one here, none here, 1 here. So the greatest number of x plus 1's is 1. Then I go to my next factor, the x plus 2. And I'm looking for the greatest number of x plus 2's in a single denominator. None here, 1 here, 1 here. So the greatest number of x plus 2's in a single denominator is 1 of them. Now this is our LCM. And this is what we want to multiply everything by. So I want to multiply it times this first fraction. I'm going to multiply it times this second fraction. Doesn't matter whether you put it in front of it or behind it. I'm putting this one behind it so it doesn't get mixed up with the negative that's out in front. And we'll multiply it times the fraction on the right side. Well, this x minus 2 cancels this x minus 2. This x plus 1 cancels that x plus 1. This x plus 2 cancels that x plus 2. This x minus 2 cancels that x minus 2. This x plus 2 cancels that x plus 2. And this x plus 1 cancels with this x plus 1. So we're left with 5 times x plus 2 minus 2 times x plus 1 equals 4 times x minus 2. So distributive property, 5 times x is 5x, 5 times 2 is 10, negative 2 times x is negative 2x, negative 2 times 1 is negative 2, 4 times x is 4x, 4 times negative 2 is negative 8. No matter where you are in math, always combine together like terms, combine together numbers. 5x minus 2x is 3x, 10 minus 2 is 8, equals 4x minus 8. And that was step 2. Step 3, solve for x. This is a linear equation because we got x to the first power. Now our steps for solving a linear equation, first step was to get rid of parentheses, don't have any. Second step was to get rid of fractions, don't have any. You shouldn't have any of those if you did your steps right up above. Third step, get everything with the variable you're solving for, everything with an x on one side, numbers on the other. So I'll take the 4x, move it to the left side, and take the 8, move it to the right side. So we've got 3x minus 4x is equal to negative 8 minus 8. When you take anything across for equals, again, your sign changes. Combine like terms, 3x minus 4x is negative 1x or negative x. Negative 8 is negative 16. Last step of solving a linear equation is to divide both sides by the number in front of your x. Well, there's a negative 1 in front of it. So we're going to divide both sides by negative 1. And we end up with x equals 16, maybe. Because remember, I put that step on there that says semi-check your answer. And that may seem strange, but the only thing we have to check on a rational equation is to make sure that this number here does not cause any denominator to equal 0. 16 squared minus 16 minus 2, I'm not sure what it is, but it's not 0. 16 squared minus 4 is not 0. 16 squared plus 3 times 16 plus 2 is not 0. Now the answers that would have caused us problems, if we come down to the factored form, if I'd come up with x equals 2 down here. If I put 2 here, for example, 2 minus 2 is 0, and 0 times whatever this would be would give me 0. And at that point in time, we'd cross that out, and we'd write no solution, or you could write a contradiction. Now that's a rational equation. Let me clear that off. Now the next topic, if I go down to the ebook and show them to you what they look like, is solving a literal equation for a specified variable. These are formulas basically. So let's look at the steps for that. A very loose definition of a formula says a formula is an equation with 2 or more different variables. Solving a formula for a variable. Step 1. Get rid of parentheses. We do that via the distributive property again. Step 2, get rid of fractions. We multiply by the LCM of all the denominators. Step 3, get everything with the variable we are solving for on one side, everything else on the other side. Step 4, if necessary, factor out the variable we are solving for. You will have two or more of that variable. And step 5, divide both sides by what is in front of / back of the variable we are solving for. And let me do a page break here. There we go. Let's take a look at a problem dealing with this. And let's first look at number 71. We got P is equal to A plus B plus C. And we're solving that for C. Then we're going to go through the steps we just wrote down. Step 1 is get rid of parentheses, don't have any. Step 2 is get rid of fractions, don't have any. Step 3 is to get everything with the variable we're solving for on one side, everything else on the other side. Now usually we're talking about terms, but they technically don't have to be terms when I say that. So we're solving for C, so I want to get everything with a C on one side and everything else on the other. So I'll take this A and move it to the left side, and take this B and move it to the left side. So when you take anything across your equals, your sign changes, so the positive A becomes a negative A, the positive B becomes a negative B. And at that point, our C is by itself, which is what our goal was. Now let's look at 79. We got 1/2 x plus 1/3 y equals 1. And we want to solve this for y. Well, you might look at this and say, well, that's not a formula. But remember, our very loose definition of a formula was an equation with two or more different variables, which is this form. So step 1, get rid of parentheses, don't have any. Step 2, get rid of fractions. Multiply everything by the LCM of all your denominators. I got 2 and 3, so my LCM would be 6. So I'll take 6 times 1/2 x plus 6 times 1/3 y, and 6 times 1. 6 times 1/2 is 3, so we got 3x. 6 times 1/3 is 2, so we got 2y. 6 times 1 is 6. Step 3. Get everything with the variable you're solving for on one side, everything else on the other side. I'm solving for y, so I'm going to take the x and move it over. So we get 2y is equal to 6 minus 3x. Step 4. If necessary, factor out the variable you're solving for, and I said you'll have two or more of them. We only have one y here. Step 5. Divide both sides by what's in front of / back of the variable you're solving for. We're solving for y, there's a 2 in front of it, so we're going to divide both sides by 2. Now specifically here, I'll divide each of these terms by 2. Those 2's cancel, so we've got y is equal to 3 minus 3/2 x. We're going to see later on this form, if I switch these around, is called slope-intercept form. And they'll oftentimes write it in this form instead of dividing the entire side by 2. Okay, now I'm going to skip these word problems because I really don't have time to show them, and go down to the complex numbers. If you want to see any of those word problems worked out, just pick ones out of the books, email me and say, can you work these? And I don't care how many you email me, I'll work them in YouTube video and send them back to you. Okay, so we're going to take a look at section 1.3 and see if my book's timed out on me. It has timed out. Okay, back into it. Okay, so we got 1.3 complex numbers. Let me clear this off. Now for complex numbers we have a standard form. And our standard form is a plus bi. Now a is our real part, and the bi is our imaginary part. Even if the problem doesn't say it, you always want to put it into standard form. Now, if you're wondering what I is, whenever you have the square root of -1, that's what gives you an I. For example, if I have the square root of -16, if I simplify that, -16 is -1 times 4 times 4. Remember the square roots, we're looking for pairs of something. Here's a pair of 4s, so they're going to come out in front as a single 4. And here we have a -1 inside the square root. And we just said here a -1 inside of the square root comes out as an I. So that's going to give us 4i as our answer. Now, in some cases, you'll be adding complex numbers. You got 3 plus 2i plus 7 minus 4i. Now these parentheses aren't doing anything, so I can drop them. So I got 3 plus 2i plus 7 minus 4i. When you're working with complex numbers, you treat the i's like a variable. So 3 plus 7 is 10. And if I think about if these were x's, if I had 2x minus 4x, I'd have -2x. Same principle. So we got 2i minus 4i. That gives us -2i. And that'd be our answer. Now you may end up subtracting. Now here, the first set of parentheses isn't doing anything, so I can drop them. Remember, if you have a minus out in front, a negative, that's like multiplying by a -1. So this is going to flip the sign of everything inside. So the positive 3 is going to become a -3. The negative I will become a positive I. Then you want to combine together like items. 5 minus 3 is 2. -4i plus I gives us -3i. And that would be our answer. Now note, we said that the square root of -1 gives you I. If I were to square both sides, a square root and a second power cancel each other, so that gives me -1 is equal to I squared. So I squared is equal to -1. You'll use that when you're doing multiplication. So if I got 3 plus 2i times 4 minus 5i, you would treat these just like variables, so we'd FOIL. So we're going to take 3 times 4, the first. We'll take 3 times -5i, the outer. We'll take 2i times 4, the inner. We'll take 2i times -5i, the last. Now when you do that, 3 times 4 is 12. 3 times -5i is -15i. 2i times 4 is 8i. 2i times -5i. 2 times -5 is -10. And I times I is I squared. Remember, we treat it like a variable. So we got 12. -5i plus 8i gives us -7i. Now, the problem with this is we can't have I squared. That's not our standard form from above. Standard form says you cannot have I squared and above. You can only have I to the first power. But that's okay, because we can replace I squared with -1, what we just said right here. So I'll put -1 in where the I squared is. So that gives us 12 minus 7i. Negative 10 times negative 1 gives us a positive 10. And that's going to give us 12 plus 10 is 22. You get 22 minus 7i. Now division. You have two different cases with division. One of them is where you have a single I down here. It might be I, it might be 2i, but you have a single I down. How you simplify this, division means basically put it into standard form, is you have to multiply the top and bottom by I. 5 times I is 5i. I times I is I squared. But remember, we said I squared is equal to negative 1. So this becomes 5i over negative 1, or negative 5i. And that's standard form. So again, a big part of division is just to put it into the correct form. Now let's look at where we have two items down below. Let's say we got 3 plus I. So we not only have an imaginary part, but we also have a real part. How you simplify this is you're going to multiply the top and bottom by the conjugate of the bottom. Now conjugate means the first part's the same, last part's the same, sign in the middle's different. This is a plus, so this will be a minus. So we're going to multiply the top and bottom by 3 minus I. Now up on top, we got 2 times 3 and 2 times negative I. 2 times 3 is 6. 2 times negative I is negative 2i. On the bottom, the nice part about conjugates is all you have to do is multiply your first parts together and your last parts. So 3 times 3 is, well actually let me write it down. 3 times 3. And then I'll multiply I times negative I. So that gives us 6 minus 2i over 3 times 3 is 9. I times negative I is negative I squared. And we know the I squared is what we don't want. So I got 6 minus 2i over 9 minus, and we replace the I squared, remember, with a negative 1. So then we got 6 minus 2i. Down below, negative 1 times negative, or negative is positive. So we've got 9 plus 1. That gives us 6 minus 2i over 10. Whenever you have a imaginary part up here, you have to split the real part separate from the imaginary part. So I'll put 6 over 10 minus 2 over 10 with an I to the side. Now 6/10 reduces to 3/5 minus 2/10 reduces to 1/5 with an I to the side. And that's our answer. Now we have our powers of I. We've got I to the first, which is I. We got I squared, which we said was negative 1. We got I to the third, which if I multiply these two together, I to the first times I squared is I to the third, so I times negative 1 is negative I. I to the fourth. Well, I squared times I squared would give us I to the fourth. So negative 1 times negative 1 is a positive 1. And then we're going to find that this pattern repeats. So it repeats in a pattern of 4. I, negative 1, negative I, 1. I, negative 1, negative I, 1. And goes on forever like that. So that's our powers of I. Now if you have a very large power of I, for example, I to the 201st power, you probably don't want to build this table out that far. So there's a shortcut to it then. What you do is you divide by 4, and this is old style division with your remainder. So 4 goes into 25 times. 5 times 4 is 20. Subtract that. That disappears. Carry down to 1. 4 doesn't go into 1, so we put a 0 here. 0 times 4 is 0. Subtract that. And this would be our remainder. Now, you can rewrite this as I to the remainder when you divide by 4. Which means our remainder was 1, so I rewrite this as I to the first, and I to the first is simply I. And that would be our answer. And that was complex numbers. Let's see, we did all three of those. So let's go down to quadratic equations. We got zero product property, square root property, completing a square, quadratic formula, discriminant. Solve an equation for a specific variable. Let me clear off this tablet. And we'll see if my ebook is timed out again. I can do a new page, but usually after I do that twice, my application bombs off, so it's easier just to do it that way. Okay, so we'll go to quadratic equations. Oh, good, didn't time out. And here's the zero factor property, or zero product property as I call it. Okay, so actually let me grab a drink real quick. So they call this the zero product property. I'm used to calling it the zero factor property, so you probably hear me slip a few times. And it says, if you got something times something else equal to 0, that's pretty vague, but it really is that vague. It can be anything, just as long as this is a product. Then you set each factor equal to 0. So you set P equal to 0, and you'll set Q equal to 0. At that point, they're probably linear equations, and you can solve them down further. So let's take a look at number 15. We got n squared plus 5n equals 24. Well, there's a problem with this. Zero product property says you have to have 0 on one side. Well, that's easy. We can take this 24 and move it over to the left side. Now this is a quadratic because we have the second power, n to the second power. Now, just like before, when you take anything across or equals, your sign changes, so 24 becomes negative. Now we want to factor this, right, as a product. This will factor using the PSD, because we have n squared, n, no n, and there's no number in front of our n squared. So this factors as n plus 8 times n minus 3 equal to 0. And the zero product property says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set 9 plus 8 equal to 0, and 9 minus 3 equals 0. So that gives us n is equal to negative 8, and n is equal to positive 3. And those would be my two answers. Let's take a look at number 18. It's a little bit more challenging. We got 6m times m plus 4 equals m minus 15. Now it looks like this is already written as a product, but there isn't a 0 on this side, so it's misleading. What we have to do is actually get rid of the parentheses, get everything over one side, 0 on the other side, and then refactor it. So first thing I'll do, take 6m, multiply it through. 6m times m is 6m squared. 6m times 4 is 24m. And while I'm at it, I might as well go ahead and take these two and move them over to the left side. Because I know I need 0 on one side. So the positive m becomes a negative m. The negative 15 becomes a positive 15. So then we got 6m squared, 24m minus m is 23m plus 15 equals 0. And I don't think I see how to factor this. A lot of these I can just look at and see. I think I see it. But let me show the key number. So I'm going to take 6 times 15, which gives us 90. Now, key number I should mention, because we have m squared, m, no m, and there's a number in front of our m squared. We'll write down all products, give us 90. We've got 1 times 90, 2 times 45, 3 times 30, 4 no, 5 times something, 18? Yeah, 18. 6 times 15, 7, I usually have trouble with one that's right here. 7 no, 8 no, 9 times 10. Add these, 91, 47, 33, 23, 21, 19. Subtract them, smaller from larger. 90 minus 1 is 89, 43, 27, 13, 9, and 1. Number we're looking for is a number in our middle term, which is 23, which is right here. So we're going to use 5 and 18. So we're going to rewrite our middle term using those two numbers. The larger number in the P column that we're using, which is 18, will always be the same sign as the middle term. So I have a plus 18m. The number I circled in the S column, S for same sign. Since the 18 is positive, the 5 has to be positive. Then I want to factor by grouping. The first group, the first two terms have a 6m in common, GCF-wise, and that gives us m plus 3. Second group has a 5 in common, and that gives us m plus 3. Now our goal was to get these parentheses the same, which they are. So I'll factor out an m plus 3, and that leaves us 6m plus 5. And now we have 0 on one side, and we factored the other side. So our zero product property says we're going to set each factor equal to 0. So m plus 3 equal to 0 and 6m plus 5 equal to 0. And solve these. So I'll take 3 over, becomes a negative 3. Here I'll take the 5 over, it becomes a negative 5. Divide both sides by 6. And we got m is equal to negative 5, 6. And those would be our two answers. Now that's a zero product property, so let me clear that off. Next property we want to take a look at is the square root property. And let me double check that. Square root property, yes. What the square root property says is if you have something squared equal to something else, then you drop off the squared and you put a plus or minus square root on the other side. And that's really vague. Something squared equal to something else. But it really is that vague. It can be anything, just as long as the entire left side is squared. For example, if I have x squared is equal to 16, the entire left side squared, so I can apply this property. We drop our squared, and we put a plus or minus square root on the other side. And always simplify your radicals. 16 is 4 times 4. Remember, looking for a pair of somethings with radical or with square roots. So bring a pair of 4s out as a single 4. So we got x is equal to plus or minus 4. You have to be careful. If I had, for example, this right here, you cannot apply the square root property right away because the entire left side is not squared. So what you'd have to do first here is you'd have to divide both sides by 2. to get the part that's squared by itself. Then you apply your square root property. You drop your squared, put a plus or minus squared around the other side. And 25 is 5 times 5, so that gives us x is equal to plus or minus 5. Let's take a look at this one. 3x minus 1 squared is equal to 24. Now notice the entire left side is squared, which is what our square root property requires. So our property says you drop the squared, you put a plus or minus square root on the other side. Now remember I said you always simplify your radicals before you go on. 24 is 2 times 2, 2, 4, 8 times 3. Square root, we're looking for a pair of somethings. Here's a pair of 2's, so they're going to come out in front. So we've got 3x minus 1 is equal to plus or minus 2. Then we're left with a 2 times 3 inside, which is 6. Take the negative 1 over, becomes a positive 1. We've got 1 plus or minus 2 square root of 6. And then divide both sides by 3. And we end up with x is equal to 1 plus or minus 2 square root of 6 over 3. And that would be our answer. One last note on this. Sometimes when you're working a problem, you work it down and all of a sudden the radical disappears completely. You get something maybe looks like this. When the radical disappears, assuming there's no I, there's an I, you have to handle it differently. With an I, you have to have your real part separate from imaginary part. Now in this case, what we're going to do, what that plus or minus means, is it means we're going to have 5 plus 3 over 8, and we'll have 5 minus 3 over 8. 5 plus 3 is 8, so we got 8 over 8, which is 1. Now in this one, 5 minus 3 is 2, so we got 2 over 8, which gives us 1/4. Now that was the square root property. Let's take a look at completing the square. After I clean this off. And it's the third item here, complete the square. Step 1. Divide everything by the number in front of the x squared. I'm going to write this in terms of x, but you can have any variable. Talk about the number in front of the x squared, that's the coefficient, remember. Step 2, take the number, the constant term, to the right side. Step 3, take the number in front of the x, the coefficient, multiply it by 1/2, square it, and then add to both sides. Step 4, back to the left side. Step 5, use the square root property to solve for x. Okay. I'm going to look at an easy problem to begin with, and then I'll look at a harder one. Step 1. Divide everything by the number in front of the x squared. There's no number in front of x squared. Step 2. Take the number, the constant term to the right side. So I'm going to take the 1, move it over. So we got x squared minus 4x is equal to -1. Step 3. Take the number before the x, which is -4, and you do this over and aside. You multiply it times 1/2 and you square it. It's always times 1/2 and it's always squared. -4 times 1/2 is -2. and negative 2 squared gives us a positive 4. And then our step says to add that to both sides. So I got x squared minus 4x plus 4 is equal to negative 1 plus 4. So we got x squared minus 4x plus 4 is equal to 3. Step 4. Back to the left side. This factors as x minus 2 squared. Now I'm not some kind of factoring genius. There's a trick to this. Whatever number's right here, right before you square it, sign included, is always what goes right down here. So there is no factoring at that step. You just have to remember that trick. Step 5. Solve using the square root property. So we got something squared equal to something else. We drop our squared, and you put a plus or minus square root on the other side. Then I'll take negative 2 over, and we got 2 plus or minus square root of 3. And that would be our answer. Now what makes this the easiest type is there's an even number before the x. I'm going to make up another example, but I'm going to put an odd number before the x, and then just the other numbers really don't matter. That's what makes it easy or hard. And we'll see why. So let's say I got x squared minus 3x plus 5 equals 0. Step 1. Divide everything by the number in front of your x squared. There is no number in front of our x squared. Step 2. Take the number, the constant term, to the right side. So I'll take the 5 and move it over. So we got x squared minus 3x is equal to negative 5. Step 3. Take the number before the x, which is negative 3, multiply it times a half and square it. It's always times a half, and it's always squared. Negative 3 times a half is negative 3 halves, and negative 3 halves squared gives us 9 fourths. Whenever you have an odd number before your x, it'll always give you a fraction. That's what makes it the harder type. And then we add that to both sides. So we got x squared minus 3x plus 9 fourths equals negative 5 plus 9 fourths. So we got x squared minus 3x plus 9 fourths. And here, this is a mixed number form. We can take the negative 5 times 4 is negative 20 plus 9 gives us negative 11 over 4. Step 4. Back to the left side. This would be hard to do if you didn't remember the trick. So that factors as x minus 3 halves squared equals negative 11 over 4. Again, whatever number's right here, sign included, right before you squared, is always what goes in at that step. Step 5. Use the square root property. So we'll drop our squared. So we got x minus 3 halves equals, and we'll put a plus or minus square root on the other side. Now we can't have a fraction inside of a square root, but that's okay because we've got a property that helps us. It says if you have a fraction inside of a square root, you can split it up. You put a square root around the top and put a square root around the bottom. Now that creates another problem because we can't have a square root in the denominator, but square root of 4 is 2. And here we have a negative. Remember, that comes out as an I. 11 we can't do much with. And we're solving for x, so I want to take that negative 3 halves over. So we got 3 halves plus or minus squared 11 over 2, and I'll put the I to the side. Remember, our standard form for complex numbers, we need to have the real part separate from the imaginary part. But that would be our answer. Now let me clear this off, and then we'll talk about the quadratic formula. And that's our fourth item here in section 1.4. Okay, so the quadratic formula says if you have something of the form ax squared plus bx plus c equals 0. A, b, and c typically are integers, but they don't have to be, but they're numbers. Then our quadratic formula says we got x is equal to negative b plus or minus square root of b squared minus 4ac all over 2a. Now our discriminant, I'm not going to show any problems dealing with this, but our discriminant is b squared minus 4ac. It's just what's underneath the square root. And you have three cases. If your discriminant is greater than 0, that means you're going to have two answers. They're going to be real. If your discriminant is less than 0, it's negative, then you're going to have two answers, and you have an imaginary part. Remember a standard form like 3 plus 2i? And your third is where it's equal to 0. You're going to have one answer, it'll be real, and it'll be repeated. I see myself running out of time, so that's why I'm not going to show the discriminant, besides just listing it there. Okay, so let's say I got x squared minus 7x plus 1 equals 0. And this would be kind of hard with the completeness square because of the odd number in front of the x. So if we use a quadratic formula, that says we need to identify our a, b, and c. A is whatever number's in front of your x squared. So a is 1, the invisible 1. B is whatever number's in front of your x, which is negative 7. And c is your number at the end of the constant term, or 1. Now we're going to go through and replace all of our variables with parentheses before we plug in our numbers. So we're going to have negative b plus or minus square root of b squared minus 4 times a times c all over 2a. Now b we said was negative 7, so everywhere I have a b I'll put in negative 7. A we said is 1, so everywhere I had an a I'll put in 1. And c is 1, so everywhere I had a c I'll put in 1. Negative negative gives us positive, so we got 7 plus or minus. Negative 7 squared is 49, minus 4 times 1 is 4 over 2. That gives us 7 plus or minus square root of 49 minus 4 is 45 over 2. Always simplify your square roots at any point. 45 is 3 times 3 times 5. Remember, the square roots, we're looking for a pair of somethings. Here's a pair of 3s, so they're going to come out in front as a single 3. So we'll have 7 plus or minus 3 square root of 5 over 2. And that's our answer. Now one last note on the quadratic formula is if you're working a problem down and you end up with 5 plus or minus 10 square root of 3 over 15, for example. This is the 3-number rule. If you can divide this number, and this number by the same number, you do so. Those are all divisible by 5. 5 divided by 5 is 1, plus or minus. 10 divided by 5 is 2, square root of 3. And 15 divided by 5 is 3. And that would be my answer. Now I can't simplify this one because we got 7, 3, and 2, which does not apply. Okay. I'm going to skip over section 1.5 and I'll go down to section 1.6, more equations and applications. And let me clear off this tablet. And the first topic says solve polynomial equations. I'm sure I'm timed out by now, but let's just see. Timed out again. Okay, so let me go back in. Timed out completely. Okay. And the ebook. Okay, and then I want to choose more equations and applications. Polynomial equation. There's really nothing exciting about polynomial equation. I might not even show one, but let me just show one, I guess. I'll look at number 11. We got 75 y to the third plus 100 y squared minus 3y minus 4 equal to 0. What's the difference here? Well, your factoring's harder to begin with. This one right here, 4 or more terms, that's factoring by grouping. So I group the first two terms together, group the last two terms together. These have a 25y squared in common, and that gives us 3y plus 4. These have nothing in common, but the first term's negative. Remember with GCF, you always factor out a negative. So factor out a negative 1, and that gives us 3y plus 4. Now our goal with grouping is get this parentheses same as this parentheses. So I'll factor that out. So we've got 3y plus 4, which gives us 25y squared minus 1 equals 0. Now 25y squared minus 1, that's two terms to minusing it. That's difference of two squares. So this becomes 3y plus 4 times 5y plus 1 times 5y minus 1. Now at this point, this is a zero product property, just what we saw in the last section. Doesn't matter how many factors you have. If you have 0 on one side and you've written the other side as a product, you just set each product equal to 0, each factor. So I said 3y plus 4 equal to 0, 5y plus 1 equal to 0, 5y minus 1 equal to 0. Here I'll take the 4 over, it becomes a negative 4. Divide both sides by 3, and we get negative 4 thirds. Here I'll take the 1 over, it becomes a negative 1. Divide both sides by 5, and we get negative 1/5. Here I'll take the negative 1 over, it becomes a positive 1. Divide both sides by 5, and we get a positive 1/5. Now I've seen some problems like this. After you get done initially factoring it, you then have to, when you solve it, you have to use a quadratic formula. So you may see that intermixed. But that's solving a polynomial equation. Now a rational equation. We already took a look at those. But let's look at number 20. I won't write down the steps again because you got those. Clear this off. Then we got 4c over c minus 5 minus 1 over c plus 1 equals 3c squared plus 3 over c squared minus 4c minus 5. Okay. Now the difference between these and the ones we saw before, end up giving you a linear equation. These will end up giving you a quadratic equation, potentially. Okay, so let's go through our steps. First step is get rid of parentheses. Don't have any. Second step, get rid of fractions. And then A is factor all the denominators. C minus 5, C plus 1 can't do anything with, but this is PSD because we have C squared, C, no C, and there's no number in front of our C squared. So we're going to have 4C over C minus 5 minus 1 over C plus 1 equals 3C squared plus 3 over c minus 5 times c plus 1. Now 2b, we have to determine our LCM. And we start with the first factor, c minus 5, looking for the greatest number of c minus 5s in a single denominator, which is 1. c plus 1, we're looking for the greatest number of c plus 1s in a single denominator, which is 1. So this is our LCM. Let me grab a drink. So we're going to multiply that by everything. So we'll multiply it times the first fraction, the 4c over c minus 5. We'll multiply it times the second fraction. And we'll multiply it times the fraction on the right side. This c minus 5 cancels that c minus 5. This c plus 1 cancels that c plus 1. This c minus 5 cancels that c minus 5. And this c plus 1 cancels that c plus 1. So we're left with 4c times c plus 1 minus 1 times c minus 5 equals 3c squared plus 3. 4c times c, distributive property, 4c squared. 4c times 1 is 4c. Negative 1 times c is negative 1c or negative c. Negative 1 times negative 5 is positive 5. Then we got 4c squared. 4c minus c is 3c plus 5 equals 3c squared plus 3. Now step 3. Remember I said solve for x and we looked at the linear equation. This is now a quadratic equation because we got the second power. And that says use the zero factor property, or you could use the quadratic formula if it doesn't factor. But we're going to try the zero factor property. So I'm going to take the 3c squared to the left side and the 3 over 2. You have to have a 0 on one side. When you take anything across or equals, the sign changes, so the positive 3c squared becomes a negative. Sally sells seashells by the seashore. I'll say that real fast. Take the 3 over, becomes a negative 3. So then we got 4c squared minus 3c squared is c squared plus 3c, and 5 minus 3 is 2. Now this will factor using the PSD. And this factors as c plus 1 times c plus 2. Zero product property. Says you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set c plus 1 equal to 0, c plus 2 equal to 0. And we get c is equal to negative 1 and c is equal to negative 2. Maybe. Remember, we have to semi-check our answer. If I put negative 1 back in my original problem, for example, if I put it right here, I'd have negative 1 plus 1, which gives me a 0 in the denominator, and I can't have that. Now the negative 2. Put negative 2 here, I got negative 2 minus 5, that's not 0. Put negative 2 here, negative 2 plus 1 is not 0. Put the negative 2 here, negative 2 squared is 4. Put the negative 2 here, negative 4 times negative 2 is 8. 4 plus 8 minus 5 is not 0. So our answer is c is equal to negative 2. Okay. Again, nothing new stepwise there. This problem becomes a little harder. Let me clear that off. I think the next topic is radical equations and equations with rational exponents. Example that is square root of 3x minus 1 is equal to 5. They do get harder than this one, but I'm running out of time, so I may not be able to show that. Yeah, some of these that have two radicals are horrible. Now, I do have YouTube videos out there so you can see more complex ones, so I'm just going to focus on giving you the steps. And just go down to the very bottom. Solving a radical equation. Of course, a radical equation, you got an equation with a radical in it. First step is to get a radical by itself on one side of the equals. Nothing in front of it, nothing after it. But do not create a fraction. These problems are hard enough without actually putting fractions in there. Step 2 is raise both sides to a power equal to the index. Step 3, if more radicals, go back to step 1. Step 4 is solve for x. And at this point, you might have a linear equation, and we'll use our 4-step method. Or you might have a quadratic equation, and you'll use the zero product property. And then step 5 is check your answers. This process gives you the correct answer, but it also gives you false answers sometimes. Say, we'll look at this simpler one in the interest of time. Step 1, get a radical by itself on one side of the equals. Well, this is by itself. There's nothing in front of it, there's nothing after it, we just got the square root by itself. Step 2, raise both sides to a power equal to the index. The index is whatever number's in this little slot right here. If there isn't a number here, it's by default 2, which means we're going to square both sides. So we've got square root of 3x minus 1 squared is equal to 5 squared. Now when your index matches a power you're raising it to, they cancel each other. So I got 3x minus 1 equals 5 squared is 25. Step 3, if you have more radicals, go back to step number 1. We don't have any more. Step 4, solve for x. This is a linear equation at this point because we got the x to the first power. So get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with an x on one side, numbers on the other. So I'll take the negative 1 over. And it becomes a positive 1. So we get 3x equal 26. Divide both sides by 3. And we get x equal 26 over 3, maybe. Remember, we have to check our answer. If I put 26 over 3 back in my original problem, the 3's would cancel. I'd have 26 minus 1, which is 25, and square root of 25 is 5, so it checks. Now that's radical equations. Equations with rational exponents. If you had, for example, 3x minus 1 to the 1/2 power is equal to 5, just in general, you can rewrite this as a radical. So you could rewrite that as a square root of 3x minus 1 is equal to 5, and then you solve it like you did before. I'm not going to show that. Now there is another type, and that's represented by like 43. So let's just talk about that real briefly. What we're applying is the power principle. That's when you can take both sides to a power. And our first one says we got m to the 3/4 is equal to 5. And the second one is m to the 2/3 is equal to 5. If you can get the entire side to a power, you can eliminate the power by raising both sides to the power equal to the reciprocal. Reciprocal means fraction flipped. So the 3/4, I'd raise both sides to the 4 over 3 power. 3's would cancel, the 4's would cancel, and would have m is equal to 5 to the 4/3 power. Doesn't say which form to leave it in. This one, I do the same thing. I'm going to raise both sides to a power equal to the reciprocal, so I take both sides of the 3/2 power. 2's cancel, 3's cancel, and we got m is equal to 5 to the 3/2. Now there's an additional item you have to take into account when you do this. Before you raise both sides to a power, if the number up on top is odd, that means there's no plus or minus. But on the other hand, if the number on top is even, that means you're going to put a plus or minus. So down here, this is not our answer. This is our answer. We have to put the plus or minus there. And so sometimes you can rewrite a fractional power, rational exponent in radical form and solve it just like we did before. Sometimes if you're working with this, you have to apply this technique on whether to put the plus or minus. Let's see, solve equations in quadratic form. So let's talk about that. Example of that. Let me see, if we had x minus 5 square root of x plus 6 equals 0. Yeah, that'll work. Okay. This is solving using the u substitution. And most books refer to that equations, quadratic in form. Step 1. Let the middle be equal to u, and the first part, let me change that, let the middle part be equal to u, and the first part be equal to u squared. Step 2. Solve for u. Step 3. Plug u equals blank back in and solve for x. Now, when you can use this method, if you can take your middle part, and never includes a number in front, the coefficient. If you can take your middle part, which is the square root of x, this middle part here, raise it to the second power. Now when I square a square root, they cancel each other, so that gives me x. If this is now equal to the first part, that's when you can use this technique. Step 1. We're going to let the middle part be equal to u, and the first part be equal to u squared. So this becomes u squared minus 5u plus 6 equal to 0. Now after you get done doing your u substitution, it should look like a quadratic. And now we can factor this using the PSD, because we have u squared, u, no u, there's no number in front of our u squared. This factors as u minus 2 times u minus 3. Now our zero product property. You get 0 on one side, you factor the other side, you set each factor equals 0. So I'll set u minus 2 equal to 0, u minus 3 equal to 0, which gives us u is equal to 2 and u is equal to 3. Now step 3 was, and this whole process is vague, I know, but the third step says plug u equals blank back in and solve for x. Every problem will be different, but whatever you said u is equal to right up here is now what you want to plug in. So we're going to plug in the square root of x for u. And we get these. And to solve this, this is a radical equation, so we'll square both sides. And that's going to give us x is equal to 4. Here I'll square both sides. And that gives us x equals 9. Now if I plug these back in, 4 minus 10 negative 6 plus 6, that checks. 9 minus 15 is negative 6 plus 6, that checks. we'd have to check it. Anytime you raise both sides to a power, you have to check your answer. But that's equations quadratic in form. Now, let me clear off my tablet here. Linear inequalities and compound inequalities. And then we got our absolute value, so let me write the steps down for linear inequalities and compound inequalities. So solving linear inequalities, our first step is to get rid of parentheses. We do that via the distributive property. Second step is get rid of fractions. We multiply by the LCM of all the denominators. Step 3, get everything with an x, all the terms. On the left side, numbers, the constant terms on the right side. Step 4, divide both sides by the number in front of the x. And we have a note that says if you multiply or divide both sides by a negative number, you flip the inequality symbol. Okay, just very quickly, let me show an example. Now 3x minus 1 is less than 5. First step, get rid of parentheses, don't have any. Second step, get rid of fractions, don't have any. Third step, get everything with an x on the left side, numbers on the right. So take negative 1, move it over. Take anything across your inequality symbol, the sign changes. So the negative 1 becomes a positive 1. 5 plus 1 is 6. And then our last step, step 4, is to divide both sides by a number in front of your x. Number in front of x is a 3, so we'll divide both sides by 3. And you get x is less than 2. Now what that note refers to is if you're working a problem down and you get like negative 5x is greater than negative 10, you would have to divide both sides by negative 5 to get the x by itself. And since you're dividing both sides by a negative number, you flip your inequality symbol. The greater than becomes a less than. Then you got x is less than 2. So that's what that note is referring to. Now our compound inequalities. Specifically, we're talking about our three-sided form. Our first step, get rid of parentheses. Second step, get rid of fractions. And those are the same methods we talked about up above. Step 3, get everything with an x in the middle, numbers on the other two sides. We're talking about terms there. Step 4, divide all three sides by the number in front of the x. Note, if you multiply or divide all three sides by a negative number, you flip the inequality symbols. Okay, so let's take a look at an example of this. This is our three-sided compound inequality. First step, get rid of parentheses, don't have any. Second step, get rid of fractions, don't have any. Third step, get everything with an x in the middle, numbers on the other two sides. So I'll take negative 1 over to the right side and over to the left side. When you take it over, it changes signs, so the negative 1 becomes a positive 1. And same thing here. So 5 plus 1 is 6, is less than 4x, is less than 8. And then our last step is to divide all three sides by a number in front of your x, which is 4. So we got 6 over 4 is less than x is less than, actually let me show that step. 4x over 4 is less than 8 over 4. So we got 3/2 is less than x is less than 2. And that would be our three-sided compound inequality. Okay. Absolute value equations. This says if you got the absolute value of something is equal to something else, then you drop the absolute value, set it equal to positive the other side, and you drop the absolute value, you set it equal to negative the other side. Now you have to have the absolute value by itself on that side. Can't have any numbers in front of it or any numbers after it. And I'll just do the setup on this since I'm rapidly running out of time. This is an example. You got the absolute value by itself on the left side. You identify your P and Q. P will be whatever's inside your absolute value. Q will be your other side. And your formula says you're going to have P is equal to Q, and you'll have P is equal to negative Q. So everywhere we had a P, we'll plug in 3x minus 1, and everywhere we had a Q, we'll plug in 5. So we got 3x minus 1 is equal to 5, and 3x minus 1 is equal to negative 5. And I guess I can finish this. Take negative 1 over, divide both sides by 3, you get 2. Here, take negative 1 over, and this becomes a negative 4. And divide both sides by 3, and you get negative 4/3. And those would be our two answers. Now we also have absolute value inequalities. Now I'll go over a little bit. I'd like to leave the last half hour for any questions you have where I'm not recording it, so because you may not want it recorded. We have two cases. Our first case is where we got the absolute value of something is less than something else. If you have it in that form, then you're going to rewrite it as negative Q is less than P is less than positive Q. On case 2, if you have the absolute value is greater than something else, then you'll rewrite this as P is less than negative Q or P is greater than positive Q. So for example, if I have absolute value of 5x minus 1 is less than 6, now the absolute value has to be by itself on the left side. Nothing in front of it, nothing after it. And the inequality symbol here will tell you which formula to use. Now, what's inside our absolute value is still our P, and this is Q. And our formula says negative Q is less than P is less than positive Q. So everywhere I have a P, I'll plug in 5x minus 1. And everywhere I have a Q, I'll plug in 6. So I got negative 6 is less than 5x minus 1 is less than a positive 6. And then you would solve it using the same technique we looked at for solving a three-sided compound inequality. Now your other case is where you got the greater than. The absolute value is by itself on the left side and you got the greater than. Well, that tells us that this is P and this is Q. And our formula says we're going to have P is less than negative Q, and then there's an or there, and P is greater than a positive Q. You have to plug it into all of that. So we're going to have x plus 2 is less than negative 4. There's no or there. Then x plus 2 is greater than a positive 4. And then you solve each of these separately. So this becomes x is less than negative 6, or here take 2 over and we got x is greater than 2. And this would be our answer. Now in the interval notation, it'd be written as negative infinity to negative 6, parentheses, because there's no line underneath, union, and then 2 to positive infinity. And I managed to accomplish it. I've gone through all the majority of the topics here. So let me go ahead and stop the recording there and then see if you have any questions.